we can't divide by a variable, so you can't ever divide by the sine of theta or the cosine of theta, because you will lose answers when you do that. So we always want to set it equal to 0 and factor things out, not divide that on both sides. So here is our first example for today. All right, if I want to solve this, okay, it's not like the first problems we did yesterday where I just have a single trig function to get by itself. It's not like the second problems where I can just pull a sine out of everything, because the 2 doesn't have one. What would I need to do here? Box method. Because it's not a 1 coefficient here, we need the full box. So these multiply to a negative 6, add to a negative 1. What would that be? So if we factor, first column we can take out a 3 sine x, 2, this way we can take out a sine x minus 1. Now we have two things equal to 0, so we set each one to 0. So first subtract our 2, divide by 3. Okay. Do I know when sine is equal to a negative 2/3? Is that one of our values from the unit? No. So we are going to have to use the calculator. I want everybody doing this with me on the calculator so we know if you're not getting the right answer. The original problem is not an inverse, so I need every quadrant when sine is negative. When would that be? Now we use our calculator to get the reference angle. If you look at the beginning, I said between 0 and 2 pi. So first of all, make sure you are in radian mode. Second, to type this in, you will do sine inverse of a positive 2/3. Do not put in the negative. So sine inverse of a positive 2/3. This will give us our reference angle, which is 0.7297. Did everyone get that? All right, so now our answers. In quadrant 3, so this is our reference angle. We found this little angle right here. To get the whole thing, what would I have to do? Well, first of all, we're in radians, so we'll use pi. If you subtract, that would take you into quadrant 2, though. We want more than that, so we would add. So to get the quadrant 3 answer, you do pi plus that. So that gives me 3.8713. How would you get quadrant 4? We always do distance to the x-axis, though.
Okay, so 360 minus that.
But we're in radians, so 2 pi. minus that. So 2 pi minus 0.7297. Okay. Those are the two answers for the first one. Second thing, sine x equals 1. When is sine equal to 1?
9 degrees.
But we're in radians, so that would be pi over 2. Okay. If you guys were ever in doubt, you can certainly check yourself. You just have to plug these into the original. Our calculator should already be in radian mode. So you would put in like 3 parentheses sine parentheses 3.8713, close 2 of them. If I type that in, my calculator tells me negative 7.569 times 10 to the negative 5, which means you move your decimal back 5 places. It didn't turn out to be exactly 0 because of rounding error, but it is extremely close. So you could always check yourself just by grabbing that calculator, plugging them back into the original. Any questions? Let's look at this one. So what would we do first? We don't have to draw the full box because it's a 1 tangent squared. So tangent squared breaks into tangent x and tangent x. Multiply negative 2 and add to positive 1. So then if we set each of those equal to 0, okay, tangent x equals 2. Is that one we know from our circle?
No.
No. So quadrants. When is tangent negative? Reference angle. We have to use our calculator, and what you are going to type in is tangent inverse of positive 2 to get our reference angle. We are still in radians because my interval was 0 to 2 pi. So we get 1.1071. So now, to get my actual answers, in quadrant 2, what would you do? Well, essentially, we found this angle, we need that one. So what would you have to do?
Take the negative minus that.
Except we're in radians, so we'll do pi minus that. In quadrant 4, what would we do?
Take 2 pi minus that.
2 pi minus the 1.1071. So those are the two answers for the first one. Second, we need to know when tangent is equal to a positive 1. When is tangent positive?
In quadrant 1 or 3.
Reference angle. We don't need a calculator for this. When does tangent equal a 1? Pi over 4. So pi over 4 in quadrant 1 is pi over 4. In quadrant 3, remember in quadrant 3 the top is 1 more, so that would be 5 pi over 4.
So I'm just basically asking some,
That's fine.
like, so quote me to quadrant 3 and then when a tangent equals 1.
Mm-hmm.
Okay.
Any other questions there? Let's keep working these. Let's look at this one. Cosine of x times cosine of x plus 1 equals 2.
Let's review and subtract 2 away.
Yeah. Why can't I just set each of those things equal to 2? Does it work that way? If I'm multiplying and get 2 for an answer, does that mean one of the original numbers had to have been a 2? No, that only works for 0. So we have to start over here. We're going to have to multiply it out. Then we have to subtract over that 2. Then we can do box method. Because it is a 1 cosine squared, we can do the shortcut. That breaks into cosine x and cosine x. Multiply -2 and add to positive 1.
Positive 2, negative 1.
So if we set those equal to 0, okay. Cosine x equals -2. When does that happen?
It doesn't.
It doesn't. Cosine can only be things between -1 and 1. If you tried using your calculator, it tells you error, domain error. So this one doesn't work. You don't even need to worry about it. It's impossible for cosine to be a -2. Cosine x equals 1, we should know that. When is cosine 1? At 0. I did not specify degrees or radians, so let's do, which one you want? Degrees? Okay, here's the difference. I said all solutions. So we talked about yesterday, if I say all possible solutions, what do you have to add to this?
160K. It's like KE something.
Where k is an integer. So k is an element of the integers. This one you could even clean up a little bit. 0 plus anything is just that, so you could even just change this to 360k if you wanted. If you were in radians, you would add 2 pi k to it. So degrees 360k, radians 2 pi k. Bless you. Alright. So far so good? Let's do some more. Find all the solutions. Okay, this one's an issue. We can't just get the function by itself because there's more than one. I can't even do like box method because we have a cosine squared and sine squared in here. Any thoughts?
Let's just do that because
Isn't it an identity?
Okay, let's use an identity. Which one do you want to get rid of? Cosine squared or sine squared?
cosine, because who likes it?
Okay, so look at your little flip chart. When you have more than one trig function, if you can't just pull out a greatest common factor, we might try an identity. Cosine squared, what could I replace that with?
And then minus sine squared.
And this looks like a really good option to me because I could add over my sine squared theta. So I get 1 equals 2 sine squared theta minus, or plus 1. If I subtract that 1 over, I get 0 equal to sine squared theta. Divide the 2. How do you get rid of a square? Square root. With that we would do plus and minus, but plus and minus 0, they're both 0. So I'm just asking, when is sine equal to 0?
0 degrees.
At 0 degrees and
360K.
plus 360k because I asked for all possible. Sine is 0 one other time. Sine is the y and at 180. Where k is an integer value. There are different ways you could write this. You could drop your 0 and say 360k and 180 plus 360k. If you recognize this is actually just every multiple of 180, so you could just say 180k on this one. I'm not going to be real picky on, you don't have to give me necessarily the nicest answer, as long as you give me an answer that works. I'm happy with it.
How do we get the 0 plus?
It said all possible solutions, so the 2 times when it equaled 0. We're at 0 and 180. When I ask for all possible, that's every time you go around the circle, so that's why we did the plus 360k. Alright. I have some more examples, but I think I want to stop here today. So I'm going to go ahead and give you the homework. Really, I just wanted to practice a few more. So tomorrow, I'll do a few more examples, and you'll probably get a little more class time to work. So you've got about 15, 16 minutes right now to work. Tomorrow, we'll practice and then have some more time. We'll do another one of those little sheets to practice the unit circle values too. And then this will be due on Friday.